But anyways, so last session we started off with your Kubernetes. We looked at your introduction, features, architecture, and then we also looked at the installation part. So unfortunately, see, with the Kubernetes, we would need multiple machines, but then since I have restrictions with my AWS account, so I'm using one single machine, and for that we are using Minikube. So Minikube is another way that we can set up your cluster on for your Kubernetes basically. So that's what we are doing here. So you just have the instructions. You need minimum of 2 CPU cores. You need minimum of 2 GB RAM, 20 GB of hard disk, and this is the configuration we are using. Okay. So let me quickly log into that instance, and we'll quickly set up your Minikube. So Minikube is, like I said, that's one way to work with your Kubernetes. Kube ADM, that's another way. You have COPS, which can be used to set up your cluster on no, that's uppercase. I may have to update the firewall, so just give me 1 minute. So now let me try this once again, and this should allow me the SSH. So okay, I'll have to do one last thing, which is to update the permissions. So I'm inside the server, so we'll become a root user. Sorry about the background, you can ignore that. Okay, so I'll quickly update the machine in case if there are any upgrades that will be done. So, but essentially what we are doing is just to run these couple of commands. So this will be to download the package. Okay, so we'll run that, and then the next step we have is to install the package. Okay, so two things. Now for this, we will also need a driver. So here, if you look at, let me quickly run this. So here, if you look at this, you need a virtual machine manager or a container. These are the options you have. So in our case, we are going to use Docker. Okay. So my Minikube is installed, and then we'll quickly install our Docker. So apt install docker.io. That should install Docker for me. And then we are going to start our Minikube. So how do we start our Minikube? We just have to run this command. Now, in addition to this command, we will also need to specify the driver, which driver we want to use. So in our case, we want to use the Docker driver. So we'll say Minikube start, and then we will say use the Docker driver. So this will start the cluster by making use of your Docker. Okay, so I shouldn't be running this as a root user. So let's exit, and this will give me a permission error. So this will give me a permission error. Okay, so all I have to do is update the permission for this, which is basically your Docker. So we'll give full permission to this. Let's run that with sudo. And we'll try this once again, and this will begin setting up your single machine cluster. Okay, so this machine will be my control machine. This will be my worker machine. So everything will be the single machine. So I don't have the multi-system architecture here. It's a single machine architecture. Okay, so this is where we had stopped in the last session. If there's any questions, let me know. If not, then we'll continue from there. We had also discussed about your pods. We had discussed about your services. There are different things that we had discussed. So what we will do is I'll show you how you can set up a simple pod. So what is your pod? Pod is nothing but your container. In Docker, we were calling it as containers, right? The same thing in Kubernetes, we call it as your pods. So all these instructions, we write it in your YAML files. Okay, so it's a simple YAML declaration that we have. So let me look at this. If I can show you one example. Okay, so here I'm creating a pod. How do I say that I'm creating a pod? You see this kind, the kind of resource we are creating. So I'm telling that I want to create a pod. Because I'll explain these instructions, but essentially that is what it is. We'll have to wait for this cluster to come up. So we'll give it a minute and then we'll see the example. Okay, so this is done. Okay, so now we make use of your kubectl. So what is your kubectl? Kubectl is your Kubernetes command line tool. So we will need to install that as well. So let me install kubectl. So this helps you to interact with your cluster. So you want to create a pod, you want to create a service, you want to create any resource you want to create, we make use of your kubectl. So kubectl is basically a tool that helps us to interact with our cluster. So now here, if you see kubectl get clusters, I should be able to see one cluster, I guess. Okay, it does not have it, so that's fine. Let's look at your nodes. Okay, so kubectl, we have only one node, which is your Minikube. So that's our control plane. Okay, so kubectl is basically what we use. Now let's say I want to create a pod. So this is what we are going to use. Okay, so let me explain what we are doing here. So let's call this as first.yaml. So all of your instructions, we write it in your YAML files. So this is your API version. So API version is basically the instructions. So based on the version that you're going to specify, the instructions will vary accordingly. And then, hold on just a minute. And then what is the kind of resource we are creating? We are creating a pod. And then we are adding some metadata. What is your metadata? Metadata is your additional information. So we are giving it a name. We are adding your label. So label, it follows your key value pairing. And then we are giving you a specification. So this is the main part. So what we want to do, we want to create a container. What is the name of your container? Which image you want to use? So this one also by default looks at your Docker Hub. Okay, so whatever the image you're specifying by default, it will check in your Docker Hub whether that image is available or not. So in my case, I'm telling dj uploads, which is my repo, and then tomcat-image. So let's quickly log into my Docker Hub account when we'll check whether that image is there or not. So repository, you can see here, this is what we are having. And then I'm looking for tomcat-image. So this is what I'm looking for. So ideally, whatever image you want, you can use as long as it is available in your Docker Hub. And then I'm specifying the ports. I'm giving it a name, and then what port number you want to use. I'm using port number 8080. So this will be my YAML file. We'll save it. And how do you execute this? To execute this, we'll use this kubectl create -f and then the file. So this will start reading your file and it will start creating the resource that you have defined. So I've created a pod and you can see it has created it successfully. Now, how do you list your pods? So we can use your kubectl get pods. And here you can see it is in the container creating status, but this is the pod we have created. Okay, you can check the logs of this. So I can use this kubectl describe pod and then the pod name, which will give me additional details about it. So this will tell you as to on which machine the pod is running, what is the current status, the logs and everything will be available here. So from here, starting from here, okay, so you can see the namespace, the service account, on which node this is running, when this was started, your labels, what is the status, which image this is using, right? And then the events as well, everything will be available for you. Okay, so now basically we have created a container. So again, if I run this kubectl get pods, it should show me one container which is in the running status. This means my container is up and running. Any questions until here?
No, Ravi.
Okay. Now, at any point when you create your pods, how do you access those pods, or rather, how do you access the application running inside the pod? For that, we make use of your service. Okay, so service is used to expose your pod to the external network so that we can access the application from the internet, basically. Okay, so here again, you should be able to find an example for that. So you see this one, service. So here is the code. So almost everything remains the same. So again, if you see here, I'm defining the API version. So let's create this. So let's call this a service.yaml. So we are giving it the API version. So we want to use the V1. And then what is the kind of resource we want to create? So this in this case, we want to create a service. First, we created our pod, which is a container. Now we want to create a service. Again, we are giving the metadata, which in this case is a name, and then the specifications. So on what port number do you want to run this? So I want to run this on 8080. And then you can say I'm doing a target port. So what target port basically indicates is, now here if you see, I have the pod and here I have the service. Now I want to map this service with this pod. How do I do that? That is where I have this target port mapping to this port. So you can see at the name I've used Tomcat port. So I'm mapping that name over here. So when I run this service will search a pod that has that name for me, and it will create it will basically map this service. And then this is on TCP port. And then imagine imagine we have multiple pods with the same name. Okay, but how do we select? That's where we have this selector. So you can see this is your label. So what this will do is this will go to your metadata. In the labels, it will search for that key value pair, and wherever it finds, it will map it. So in our case, we will have to update the service telling that this will be the label. So here, let me change it. Okay, and then your type. Now, when we talk about your service, there are different types of uh, how you can expose the service. Okay, so we have your cluster IP, which exposes the service within the cluster itself. So you won't be able to access it outside the internet. Then you have the node port, which can be used to access the service on the node machine's IP address. Then you have the load balancer. So if you want to create a load balancer for this, like application load balancer or network load balancer. And then you have the external name, which maps the service to the contents of an external name. These are the options here. So generally, if you're on like a cloud platform, you go with the load balancer, if not your node port. So the same thing I will be defining here as well. So we will say node port. So how you can see how case sensitive this is. So it follows your camel casing. So I'll save this, and then again we will execute this. So kubectl create -f and then service.yaml, and this will create a service for us. Okay, so now kubectl get services, and here I should be able to see the service. So this is the service we created. You can see the type, that's your cluster IP, and on what port number this is running on. So now if I want to access this pod, I'll have to first allow this port number. So I'll take this port number. I'll go back to my security group. Let me edit this, and let's allow this from anywhere. And then I can try doing a local host. So let's do a call. Local host on that port number. Or let me try this. It's 31306. This is not working because I'm using Minikube. So I'll have to use a cluster IP. Hold on. So let's try this one. Yeah, this might be a network issue, but if you can recall the Kubernetes session, I had showed you how we were able to access it. Unfortunately, because I'm having issues with my EC2 machines, I'm not able to show you that. But essentially in the browser, if I hit the IP address and then the port number, I should be able to see the container that is running. Okay, are you clear with the service concept?
Yes, Ravi. So the port name and the port, this one should match, right?
Correct. So here also, if you see, we are. I mean, it's not necessary, but the name. Okay, yeah, correct. Actually, this information should match. And then the label as well, the selector that you're gonna do.
If
That
there
should.
are multiple ports, then
Yes.
like, the label is useful.
Yes. So label here will be your metadata, which can be used to find the containers, the pods basically. Okay. The next thing we have is your deployment. So, say deployment can be used when you want to maintain a specific number of pods. So no matter what the situation is, no matter what the condition is, you want to always have a specified number of pods. That's where we can make use of your deployments. So it is basically creating replicas of your containers. Okay, so here if you see, I should have an example for this. Let's go back to the repo. So here this deployment.yaml. So you can see here we are creating a deployment and here is my replicas. So let me take this and I'll explain the code to you. So that's my API version. What kind of resource we are creating? What is the metadata? So metadata is completely user defined. You can give whatever you want, but that is essentially your additional information. So any additional information you want to specify, you can specify it in your metadata. Okay. Then we have the specification. So here we are defining the specification. So what do you want to do? So I want to create three replicas. Three replicas of what? Basically the pods. And then I'm telling it to match this label. So basically telling, select for this label. So if there are three pods, leave it. If there are no, if you don't have three pods, then create it. And then again, I'm giving some metadata to it. And then that's my container specification. So I want to create the container. What's the name of it? Which image you want to use? And what is the port number you want to open? So here, these are the main things, that this one and the replica. So how many pods do you want? So now when I execute this, so let's execute this. So kubectl create and then the deployment. So this will create the replicas, whatever the number of replicas I have specified, it will create that many containers for me. Okay, so let me do a list here and I can show you. So yeah, so here you can see that's 1, 2 and 3. Okay, so I have three containers running, and if you see this kubectl get deployments, this is what we have created. So 3 of 3 up to date available. This was created 33 seconds ago. This is one use case, one advantage. Now what's the other advantage? Now let's say if something goes wrong, let's say this container was deleted. Don't want the. So let's say this container, this pod was deleted. Okay, so let's say delete the pod, which is this one. So let's say something happened and this pod was deleted. Now you see here what will happen. You see this last one. A new pod will come up automatically. Okay, so that's the advantage of your deployment. So deployments will always make sure that it always maintains the specified number of pods for you. Okay, so this can be used to make your application highly available and also fault tolerant. Okay, so this is essentially what your deployments are. Any questions?
No, Ravi.
Minutes.
No, sir.
Okay. So I want to talk a bit about your service. So I told you that. So you also have the option of creating the service from the command line itself. One option is using the YAML files. If you don't like that, you can always make use of your command itself. So you can say kubectl create service, the type of service, name of it, and the port mapping. This is also possible. But I would say stick to the YAML files because that is what you will mostly end up using when we talk about your Kubernetes. Okay. The next thing we're going to look at is your ingress. What is ingress? Ingress can be used as a router. Okay. So imagine we have an application which is hosted on example.com. Okay. Now you want to do something known as a path based routing. What I mean by that is if I hit example.com/image, now that's a path, right? It should go to one service. Likewise, if I hit example.com/video, it should go to another service. So basically your path based routing. That's where we can make use of your ingress. So Kubernetes ingress, that's your collection of routing rules that govern how external users access different services that you're running in your cluster. So imagine you have 5 different services. Okay. Now, based on the user request, you want to access the services. So if I say service 1, it should go to service 1. If I say service 2, it should go to service 2, and then so on. That's where I can make use of your ingress. So for example, under this, what happens is you'll have service. For each of these services, you'll have your pods, and this service will be behind an ingress controller. For this, you'll create an ingress service. As a user, we will hit the ingress service, which will go to the ingress controller. It will evaluate the rules, send it to the respective service, which in turn will hit the pods for us. Okay, so basically that's your routing. So for our example, we will be using the Nginx ingress controller. Okay, so um, here in the repo, you should be able to find examples for this. This one, okay, this particular folder. So here we have the examples. So first thing, we will have to install our ingress controller. Okay, so here this one will help us to install the ingress controller, this YAML file. Okay, so I'm not going to explain this, but this will help us to install the ingress controller. So we'll take this file. So we'll take this file and let's create a new folder. Let's call it as Nginx. And the first we are going to create is a deploy.yaml. Okay, so this will be the code and we will execute it. So this is to create the ingress controller. So here you can see this one. This is we have created a namespace. We have created a namespace service account. That's your authentication and everything. But here, if you see, this is where we are creating the ingress controller. Okay, so the ingress controller is created. Then we are going to create our rule. So here, if you see, this is where we are creating our ingress. So let me take this and I'll explain this to you. So what are we doing here? We are creating a ingress. That's our metadata, and there's my specification. So what is the class name? Nginx, and what's your rule? So if the request is coming over HTTP, and if the path says /apple, it should go to this service on this port number. And if the path is /banana, it should go to this service on this port number. So this is basically your routing. So in the URL, if I give, let's say example.com/apple, it should hit a service with this name. And if I hit example.com/banana, it should hit the service with this name. Does this make sense?
Yes, sir.
Yes, Ravi.
And then for this, we will have the respective pods and service. So you can say I have pod 1. So here I have the pod as well as the service. Okay, so let me take this. So pod1.yaml. So we are creating a pod. I have a image that I'm using. And if you see the service, so this is what we are targeting. Okay, I'm telling my ingress that, hit this service. This service in turn will hit this pod for me. So you can see this selector, it is here. So it will select this. Likewise, we will have your pod 2. So this is my pod 2. So here you can see this is my Apple. So you can see the service, and this service will hit this particular pod for me. So let's create this. So kubectl create -f. We'll create pod 1. We'll also create the pod 2. So we'll execute both. Okay, so it will take only one. Okay, so you can see the pod is created and the respective service is created. And now we'll create 2. So this will create the respective pod and the service. And now we will create the ingress. Okay, so there's my ingress created. So if you look at the resources, so kubectl get pods. So you can see there's my Apple banana, and then Apple app and the banana app. There seems to be some problem here. You can see this image pull back off. There might be some problem. So let's quickly look at it. So kubectl describe pod and the pod name. So this is complaining, hey, I'm not able to find an image with that name. Okay, so you can see failed to pull. So let me quickly validate this. HTTP. I have it. DGR uploads LO. DGR uploads LO ADS. Okay, I guess I may not have the latest version. Hold on. Yeah, so you see here the tag, it says 1.0, and this one is looking for latest. You can see this one, it is looking for latest. So I'll have to, let me delete this. So kubectl delete, this will be pod 1. Yeah, so you can see this Apple that is running. So let's edit this. So this should be looking for my version 1.0. Okay, so let's create this once again. Okay, so kubectl get pods, and now you can see this is in the container creating status. So I should be able to see the service. So here you can see there's my Apple service, then there's my banana service. And if you look at the ingress, so kubectl get ingress, here is the ingress that we have created. Now, essentially with this, if I take the server IP, okay, this will not work because I'm using Minikube. But if I was running this on EC2 instances, like multiple EC2 instances, let me quickly allow a couple of rules. One will be HTTP, the other would be 8080. So if I was running this on IP, like multiple machines, if I gave the server IP, so if I give server IP slash Apple, this will take me to the Apple service. And if I gave banana, it will take me to the banana service. Does that make sense?
Yes, Ravi.
Unfortunately, because of the restrictions I have, I'm not able to show you, but this is essentially what will happen. If it was working, that is essentially what will happen. It would show you what is running in pod 1, and if I give /banana, it would show me what is running in pod 2. I think I showed you this example when I was covering your Kubernetes, if you can recall, right?
Yes, Ravi. Yeah, I'll check the previous videos.
Yeah. So yeah, I'm gonna stop here. Okay. I need to go. My son is a little crying. So in the next session, we'll talk about your dashboard, and then we'll look at some other topics as well. Okay. Thanks a lot, guys.
Thanks,
Bye.
Ravi. Take care.
Thank you, sir.